and then just scroll to the right. All right. What's up, guys? Happy Saturday. GM. Can you guys hear me okay? Yep. All right, awesome. Week 3. How's everyone feeling? Yeah, good? Good? All right. We're almost over the hump. Four more weeks. So real quick, some logistics. I'll do some intro slides like usual. We'll open it up for immediate questions and roadblocks. What's up? How are you doing? She's got some questions. Or he? She? Okay. We'll do week 2 student demos. There's not that many. Hopefully, I don't know if you guys submitted more, but Cloud's got the list, so I know there's 2 for sure. Hopefully there's more. And then we'll do slides and then reverse classroom, just like we've been doing every week. So just for announcements, ETH SD is officially a Polygon guild. Woo, let's go. Super exciting. What does this all mean? Well, Polygon has sort of these developer advocate programs. Anyone can start up guilds in their cities. So we're the first one to have a guild on the West Coast, which means we'll get support from Polygon. Maybe we'll get some cool merch. Maybe we'll get some of their DevRels over to talk about the things they're building with the ZK VM or Polygon ID. So essentially building a strong relationship with Polygon and getting support from their broader team. To kick this off, we'll be doing an event next Tuesday here at Edge from 6:30 to 8. I'll be speaking with Matthew Crack, who's head of Polygon BD and DevRel at Chainstack, which is an infrastructure provider. And he's been really pushing forward sort of the Polygon initiative at that company. So it'll be cool to hear from his side the cool things that Polygon's working on, and we'll talk a little bit more about what it means to be a Polygon guild. Another update, so Chainlink. So we're building a relationship with Chainlink to help direct students from this program directly towards their recruiters. So we'll have a portal for students in the ETH SD Bootcamp that finish this to be able to apply directly to some of their positions if you guys are interested. So this is the first of many partnerships that we're providing for the ETH SD Bootcamp. If you guys are interested, next week we should have that portal open so you guys can actually go ahead and apply, and you'll get directly tapped into their technical recruiters. So kind of going around that process because you guys are all vetted, right? You guys are working, we can vouch for you guys. You guys are working on Solidity soon and becoming Ethereum developers, and that's the kind of stuff these companies want to see. Okay, week 2 recap. So the week 2 project was pretty easy, right? The modules were tough. but fundamental skills in sort of understanding blockchain architecture, data structures. We did a lot of recursion. We did a lot of trees, so Merkle trees, binary search trees, Patricia tries. But hopefully the project wasn't too hard. So if you guys got through the modules, the project was kind of a cakewalk. With that said, to recap, we talked about the difference between UTXO and account models. Bitcoin uses UTXO, Ethereum uses account models. Trees, right, binary, Merkle, and tries, and then Ethereum architecture, and lots of recursion. I'm just curious, like, whose first time was it working with recursion algorithms? Nice, okay, a few of you guys. What do you guys think?
I think it was the proof, the Merkle tree proofs, that was insane. That was like really hard.
Yeah.
Like constructing them, like I think was like it was trivial, but the proofs were very difficult.
Yeah, that was definitely the crux of the week, building that Merkle proof. Okay, well, hopefully we're over kind of the hard stuff. Now we're going to get into more of like Ethereum fundamentals, working with Ethereum, and then we'll ramp back up as we learn Solidity. One thing I wanted to just cover is before we get into week 3, this diagram is really, really important to understand. And if you kind of understand this diagram, you can wrap your head easily enough, or more easily around Ethereum and eventually Solidity. And I think this course sort of walks you through this stack from top to bottom. And so, starting at the top, you'll see these block headers and what makes a blockchain, right? You've got blocks that are chained by hash algorithms and secured by consensus protocols. These are the types of things that we talked about in week 1. In week 2, which you just did, we kind of start going down more into these tree structures. So, what's below the state root is this Patricia Merkle trie. You've got a transaction root, you've got a receipt root. Week 3 is going to be all about transactions, so kind of diving into what's underneath this transaction root. And if you really think about this, what's in the transaction root, this sort of data is applied to the state root, and you can always reobtain state by running through these transactions. So these are kind of like it's kind of like the cookbook or the blueprint to get you to the next block. And week 3 is going to be all about transactions, interacting with, sending transactions, and then reading data back from the state root. And then if you go down all the way to the bottom where you see this little black box that says code, that's Solidity, right? So weeks 4, 5, 6, and 7, you're just working on that thin little layer, which is Solidity. And there's a ton to learn there, right? Because it's a Turing-complete language. But just to show you that, like, the reason why we're going through these fundamentals with week 1, 2, and 3 is because Ethereum's a lot more than just Solidity. So hopefully that gives you some motivation and kind of some understanding as to why we're going through some of this harder stuff. With that said, are there any questions from week 2? All right, you guys slayed. Let's go, congrats. If you have questions, right, you can ask any of the mentors or myself after. So just talk a little bit about the rubric. Obviously, this project was a lot more straightforward than last week, but we're always going to have 1 or 2 points dedicated towards one, being able to describe your project, because this is really important. It's important to be able to communicate what you've done, being able to walk through your code, just in any setting, whether you're at a hackathon or you're applying for a job or you're actually at your job. Being able to communicate your skills is super important. Being able to walk through your code and communicate that in a way that other people can understand is an important skill set. So we'll always have 1 or 2 points for that. Your project's got to compile and run. And then the last 3 points are really specific to this project. So A, we're able to create a Merkle tree from the nice list, which is just an array of names. 3 points if you were able to generate the Merkle proof from a specific name in the nice list. So this is taking sort of a node, a leaf, and generating a proof. This is like what you actually implemented, right, in the modules, and now you're just using a library to do this. And then 3 points if you were able to verify that the name exists on this list from the server side. So the server takes in your leaf node, and it takes in your proof, and then it has a Merkle root. And with those 3 pieces of data, it's able to verify that the leaf that you passed in exists. And that Merkle root never changes. It should be immutable, because that's sort of your checksum, right? If you download a file, if you download a huge file, you'll see that there's always like a SHA-256 checksum. You can kind of think of Merkle roots in that sense, right? It's a way to verify that the data exists in that tree in a much quicker way. With that said, let's jump into student demos. Yeah, guys, let's go. I don't have the list, but Cloud, do you have the list? Do you know who's? Okay, cool. Awesome.
Yep. So we're gonna start. Well, we only have 3 submissions this week, and I just want to say for everybody, I urge you guys, just like Chad said, to present. It's those soft skills that are gonna set you above the other developers. So getting in front of everybody, talking, all those things are great skills to keep practicing. They're gonna make you great devs. Today, I know for sure we got Namdar. Do you want to start for us again? All right.
It doesn't matter. How's everyone doing? GM. Okay, so I'll start with, everything's zoomed in on my end. Okay, so I'll start with my server side. Here you can see that I created the Merkle tree from the nice list, got the root, printed it out, and then it's here. And if we go to my client side, you can see where the name is, where the nice list is, and then getting the proof and then sending it through a post. So I have my server running down here. So if I send this, you get a toy robot. And if I put a name that isn't in the list, so like Ted, for example, you're not on the list. So now the question that I had was, if I go to the nice list and I put comma and I put if I do put Ted and then save, and I go to the index server and I run again, Ted is still not on the list. Can anybody tell me what step I missed?
So, does anyone here want to answer him?
She wants
it. You have to rehash.
Yeah, exactly. That's it. That's the only reason I wanted to come up here and ask that question. Yeah. I can show the rehash if you guys want, but she got it. Ted's on the list. Hey. Thank you.
Awesome. So up next, we have Vanessa herself to present. And quick question to the crowd. Does anybody know why a Merkle tree is an efficient data structure? Anyone want to answer that?
Hello. Yeah. So my understanding might not be the actual way, but my understanding is that it's because you're only really sending the proof instead of the entire tree, which is like the log2 of the amount of leaves that you have, and of like the amount of like kind of like proofs that you have for each of the branches, and just and you just have to store the root itself on what you're comparing it to, and the actual piece of data that you're checking is inside the structure. I think that's the best way of describing it.
Yep, you're pretty spot on there. So yep, we store the Merkle root hash, and we only have to concat a hash from the leaves, only the leaves that are necessary to find that hash as well.
Okay, so I kind of lost my voice, but we're gonna still do this. All right, so I kind of went down within like numbers of instructions so I could just understand how this actually works, because Cloud helped me out with this. But the first step we had to do was create the Merkle tree for the list. So this is what we do here. And then the next instruction was we had to hard code the actual root of the Merkle tree. So we did that by getting the root for Merkle tree.getRoot. You console log that root, and then we set it here. And then let's check out the client. And then the client, we have to first create the name that we want to search. So we set that to name. We then get the index to see if the name even exists. And then the fifth instruction is we have to then create the proof. And so we create the proof by calling getProof off of Merkle tree and passing in the index. The sixth step is that then we pass in the proof and the name to the server. And now we go back to the server, and we want to grab the name and the proof that we just got from the server so we can destruct that from body. And then lastly, we can just set this variable to verify proof. We pass in the proof, the name, and the Merkle root, which is the root that we have up above. And yeah, then this should basically let us know if this is actually working. So we'll get the server running first. So the name does exist, and then if we try this with a different name, like that, the name does not exist because it's not in the list. Cool.
Wonderful, wonderful. And Babik. Hello. No problem. Is there anybody else who last minute wants to present? So luckily, why am I so loud? So week 3, we're here. You finally get to work with Ethereum. So we're going to be diving into the state machine, and then we'll be dealing with some of the front end aspects of creating decentralized applications today. So still not Solidity, but we are getting a lot closer to a lot more of the fun stuff. Here we have a clear problem. So let's, it's always the soft skills. There we go. That should be the only one that's messed up. So we're going to start this week. We're going to talk about Ethereum. And this week it's pretty dense in the readings. And so it's not so much coding this week. There's not too many modules that you'll be going through. So you'll be able to get through this week just by following along with the chapters, which is really nice. So for those of you who may be catching up. So we'll start off with this intro to Ethereum. It's going to be, Ethereum's deterministic, right? It's pretty much a computer is what they're trying to get the point across here. So open source, decentralized, it's a computing infrastructure and it executes programs, and that's what we call the smart contracts. So you have thousands of computers all over, and they are all interacting with each other, but they all run the same program, right? So you can look at Ethereum as actually just being one computer, but you can run its software anywhere. So it's the first singleton that's not localized, right? So there's only one Ethereum, but it doesn't actually live in any machine. It just lives all over. It's censorship resistant, it's ubiquitous and accessible, right? So all you need is Wi-Fi to be able to work with Ethereum. And if you want to write to Ethereum, you need to own some ETH. So the barrier to entry is pretty low, which is really great. Anyone in the world can participate in Ethereum. Multi-user, right? It has nearly an infinite range, which is 2 to 160. And I tried to actually get a visual representation of that number. It doesn't exist. So yeah, it's really large. It's verifiable and it's auditable, right? So people can audit contracts. There's an entire market just for that, making sure that the smart contract does what it says it's going to do, right? And then we can verify that, and we're able to trust these things because of that. So once you deploy a smart contract, it's immutable by nature, censorship resistant, and there's only a couple clauses where you can actually change anything about it, whether it be upgradable or destroy it. Ethereum is Turing complete, right? So it supports basically any Turing complete language. And to be Turing complete means to follow the guidelines that Alan Turing has set. So you can build a lot of unique applications with this that are going to end up being decentralized because we can use a lot of different languages to talk with it. It's a virtual machine, so essentially what that means is that we are emulating a particular environment. So that means it's going to run the same on everybody's machine here, whether you have Windows or Mac, right? We don't have to really guess what's going to happen, and we can be certain that it's going to run the same for everybody. Now, one of the things with Turing complete languages is they allow loops. So how can we prevent a loop from running infinitely? Right? That's where we start getting into gas. So we add cost to be able to interact with Ethereum, right? To write to it, to execute a transaction, it costs money. So if you want to do something that would require the nodes to take a lot of computational power, it's going to cost you a lot of money, which isn't really feasible, and this kind of stops bad actors. So gas is a measurement of cost to each operation, right? And you're going to always pay more based on the complexity of the task that you're trying to run. So sending a transaction, not very complex. If I want to send Ether from one person to another, that's going to be relatively cheap, right? But doing something more like maybe minting an NFT, minting 10,000 NFTs, we've seen these gas prices go exuberantly high. One of the most famous ones being like Other Deeds, where people were paying ridiculously high gas prices for these things. So the cost of gas is fixed, and it's kind of an interesting way to wrap your mind around what gas is, right? So the units of gas are fixed, right? So 1 unit is always 1 unit, but that price, the price of that gas is always fluctuating, right? And that price is fluctuating usually based off the price of fluctuating based off the blocks before it and the amount of gas that was used in the block before it. So we also have operation codes, and these op codes do a bunch of fun things. You can use these to essentially interact with Ethereum. So we have arithmetic, current transaction context, temporary memory, persistent memory, and control flow. And you're going to go through all of these throughout your modules this week. And they're good to spend some time on, get familiar with. So I would definitely dive into these a little bit more and just kind of understand what they're doing. Different opcodes cost different amounts of gas, right? So depending on how complex the opcode is going to be how much units of gas that you have to pay in order to execute that operation code. We also have forks. So one of the most classic forks is Ethereum to Ethereum Classic, right? So it's just designed with the ability to conduct upgrades. We can make Ethereum better through these forks. But forks require the nodes to update their client versions. So there's like 3 popular clients for Ethereum. And if we're gonna do a upgrade, then all of the nodes have to be, in consensus for that upgrade and essentially all accept it and update their client version. Now, when some of the nodes providers decide, no, we don't want to upgrade, that's when we get a fork and you'll have 2 separate chains. And that kind of almost happened with the merge when people didn't want to move to proof of stake, right? Some of the nodes were threatening to basically say, hey, we're going to stay proof of work. So September 15th, 2022, proof of work to proof of stake. If some of you were at the merge party that ETH SD threw, then we had a great time for that. So that was a really big momentous occasion for Ethereum. It made it more secure. I think the most important part of this was that it became less energy intensive, right? So a lot of people were saying, proof of work was requiring a lot of energy. It wasn't green, now we're carbon neutral. So that's a great thing. However, now you have to stake 32 ETH. And when you stake this 32 ETH, you become a validator. And when you're now validating these transactions, you get rewards based off what you validate. If a malicious actor does something with his validator, they'll be slashed or they'll lose their ETH or lose half of it, right? And this is to make sure that people continue to, act in favor of the network. So what does this really mean for Ethereum developers? Well, the most important part that Alchemy wants you to know is that it affects finality. So you can be confident that your block will not change or be forked away. So they added 2 new levels of finality, and these aren't the only levels of finality, but these are the 2 new levels that were added. Safe, which basically means it's unlikely to be reorganized, and then they're going to go into epochs, the amount of time that is for both of these levels of finality, and then finalized, meaning it's accepted by 2/3 of the validator, and it can't be reorganized outside of manual intervention, which basically isn't going to happen. So if it's finalized, we can trust that that block is true and accept it. The states of finality are earliest being the most proven, all the way down to pending, right? So gas price changes with every block, kind of like I was saying before. As we know, gas can be very unpredictable and it can get very costly, right? And this kind of like blocks just your average person from participating. When it starts costing, if you want to use Ethereum and you have $100 worth of Ether and it's costing you $20 worth of Ether, it's not very fun or economically feasible for that user to continue, using this chain. And it's been a problem that scared a lot of people away. With EIP 1559, we have better gas price calculations, right? So these are the units of gas. We go from whey to ether, whey being the smallest. I would say the ones that I really only deal with is whey, gwei, and ether, right? I've never really had to deal with quay, mway, micro ether, or miller ether, but they exist. And if you ever want to have fun with some of those units, So each block has a maximum amount of gas that can be used within it. So it's got a capacity of 30 million gas. So once that block reaches 30 million gas, no more transactions are accepted, no more minor tips are accepted, you can't send a priority fee, right? That block is full. Ideally, you want to reach just a target of 15 million gas, right? And this is units of gas. This isn't the price. This is units of gas that you want within your block. So if the block prior to the next block is above 15 million, what do you guys think is going to happen? And if the price of the block is below 15 million, the gas price goes down. So actually, I want to show you guys something pretty cool. So this is a fun little website to kind of like understand gas and transactions. This website's called ETH Street. So you can see these are all of the people who have basically low fees. They low gas. They're waiting in line, right? They're just waiting in line for somebody to take their transaction and actually, you know, do something with it. Now, all of these places are houses, so these are some of the most popular places. You know, we have Uniswap, Tether, OpenSea's right here, Chainlink, right? So like OpenSea, during a popular NFT mint, like you'll see tons of people just running out of this house. And each one of these buses is a block. So these people wait in line, they get in the block. If there's room, they'll get in. And then when this bus kind of ships off, yeah, now it's been pending actually. So it would technically be pending, but it'll start to kind of, it's like a good little visualization. Yeah, it is it is a little town. But it's a cool little visualization if you ever just kind of want to like see. I know like days where gas prices are just absolutely crazy. I like to come here. Like this is kind of funny because all last year, kind of during the bull run, like this entire square part, even before the fee line, would kind of look like that. Yeah, this is live. This is live. Yeah. No, this is the network congestion happening like right now. So yeah, like when things are going crazy and it's the bull run and everybody's using Ethereum, yeah, you'll see. And as you can see, kind of like Bitcoin isn't being used as much. I honestly don't know. They're kind of going down to the bottom. Any of the mentors understand kind of what it means to see transactions leaving a block? Could be a possibility. It looks like maybe some of them are moving into other blocks. Oh, it could also be an ORF. We can definitely look into that. We'll get you an answer, Bralia. Yeah, more complex transaction, right? So like these guys here waiting to get in to the bus, like this bus isn't full, but yeah, they gotta wait their turn until somebody has some room for them. So that's ETH Street, which is a great little resource. So we talked a little bit about counts last week. Well, UTXOs versus Ethereum's kind of account-based thing, but we're going to get a little bit more into Ethereum this week. And these slides are dense just because there was a lot of reading. These are, like, honestly, just gist of them. Externally owned accounts, EOAs, contract accounts, right? Contract accounts are smart contracts. EOAs are your typical public-private key, right? So EOAs can have a balance. They can send transactions to smart contracts. And they're controlled with a private key. Contract accounts are programs that just run in the blockchain execution environment. They're written in languages like Solidity or Viper, and always test your smart contracts, right? Toby went over this. You're in literally the most adversarial environment ever. You're securing money or you're generating money, and there is somebody out there who spends all their time trying to take that money. So test. I think last year we had like over $600 million in funds stolen from protocols. So something kind of cool to look over in that regard also is websites like Code4 Arena. So I don't know how many of you ever heard of Code4 Arena, but this is an auditing platform. So companies come here and they put up their smart contracts and they ask people to audit them. People who successfully audit them win money. So you can see the leaderboards for last year. You know, some people are running this as companies, some people are running this as individuals. But the payouts can be quite high, right? Last year, WatchPug made over $427,000 just auditing contracts, whether he did that on the side or daily. That was his full-time job. Regardless, these were his payouts. And you can see, I mean, millions of dollars went through Code 4 to basically make sure that these protocols keep their contracts safe. If you deploy a smart contract with an error, more than likely, unless you have thought about this very hard and expected potential errors, that contract is no good. Let's just say, like, I know a long time ago when people were deploying ERC20s, Uniswap ended up upgrading their router. So they had the Uniswap V2 router and they moved over to V3. If you were kind of developing in that time and you had to, in your smart contract, you had to write the Uniswap router. It was a variable. If you just, the week before you were about to launch a token and you put Uniswap V2 and you didn't write a function to update the router, right? That contract was always stuck on version 2 of Uniswap. There was no getting it to V3. It's absolutely there forever. So a lot of tokens at that time were redeploying their contracts and airdropping their users. And if they didn't have a lot of money, they had to also pay the deployment fee for Ethereum. So just be careful when you write.
Hello. So just to kind of recap on that, like if you are like just on the weird side of like, okay, I'm going to err on that side of caution, I'm going to plan that I'm going to have to change things in the future, you basically have to have a function that can like update its, like you can redirect its update or something, or?
Yeah, you could have a function that like, you could have functions that update variables that were only callable by the contract owner. Now, there are ways to upgrade contracts, right? So Open Zeppelin has upgradable standards, right? That you can make a contract upgradable, or they also have proxies where you can redirect where your contract points to. And it's a weird area and a very gray fine line depending on what you're building. So there was a point where we knew that we had upgradable contracts through Open Zeppelin, but when people were deploying NFT projects saying basically, hey, I'm going to have this upgradable contract in the future, right? So that way this contract isn't just set in stone. Users didn't want to use it. Well, why wouldn't they want to use it? Well, if you're kind of making a startup, you're not trusted. It's hard to say, well, I want to use a contract that one day could be upgraded to do something, whether it be good or malicious, right? So it's something that you have to talk about to the person that you're building with. We're going to get into JSON RPCs. This is like what I think is the fun stuff, right? So you can use this RPC bridge to connect a dApp, so your client, to an Ethereum node. This is pretty much the API standard for talking to Ethereum, right? It's similar to REST. All nodes everywhere contain a JSON RPC interface. So that's you're writing your dApp. You can use JSON RPC to talk to all of the deployed nodes in the world. So we've already been working with REST APIs for the last 2 projects. So get, post, put, delete, right? The CRUD standard, create, read, update, delete. We send a request, get or post it. That's mainly what we've been doing. Talks to a database, send something back to our client. With a dApp, it's the same thing, right? You're gonna make a request. However, now you need a provider. So you need somebody that interacts in between you and the Ethereum node, which is typically like a wallet, right? So your MetaMask, and it's going to be able to talk to a JSON RPC interface, and you'll be able to send requests to write and read. So client side, you formulate this JSON RPC request, your wallet acts as a provider, nodes receive the request. So they're going to have you set up an Alchemy account and make your first JSON RPC request. And actually, let me backtrack because I forgot to add. They have, this week, you're going to have a challenge where you have to send a transaction. So this week, ETH SD, we're requiring that you send that transaction. However, it's going to be in the chill zone. They have this idea of a tipping service in Alchemy. So you'll be going to Gorelli, you'll be getting testnet funds, and you'll be sending these testnet funds to everybody here. So you guys are going to go into the Discord, you're going to make a fun fact, and then if you think somebody's fun fact was interesting, go ahead and tip them. You guys may have saw I dropped the first fun fact in there just to give you an idea of how to do it. So you'll copy that Gorelli address. The things that are important. When you're developing, you never want to develop from your main wallet. They're going to have you download Apex. That's optional. You can make a second Chrome browser profile, re-download MetaMask, whatever you're comfortable with. But mainly what they're trying to get through to you, don't develop with your own wallet, right? Make sure that you have a second wallet to develop with. After that, your second project is going to be making this JSON RPC request, and you'll have to set up Alchemy account and use their API keys. We get into Ethereum nodes, the different types of nodes. So we got full nodes, archive nodes, light nodes. Does anybody know the difference between these nodes? So a full node and an archive node are kind of similar, right? They both pretty much have the entire history of the blockchain. Difference between archive and full is that archive has data that isn't necessary for a node to basically send like RPC requests, right? A light node is only carrying like the most current blocks, just way smaller in size. They're going to go more in detail on those. So they get into transactions, right? The only way ever to change state in Ethereum, it costs money, and it's through a transaction, right? These are initiated by EOA accounts, right? So externally owned accounts. All write operations cost gas, and they always require a private key. Do you guys think that a smart contract can make a transaction? Not on its own, right? So technically, right, because we have oracles now, right? So they can make transactions. They kind of act as a third party. But without an oracle, smart contracts can't necessarily call transactions. It always requires a third party. Somebody always has to press that button. Smart contract is no different than a vending machine. It's got a bunch of different options on there, but someone has to press the option, right? Now we have oracle providers like Chainlink and Gelato, which help make automated smart contracts. So we only have two types of transactions, which is contract creation and message call. Contract creation is exactly what it sounds like, deploying code, creating a contract from your private keys. Message call, sending some type of data over the network, or calling a function on a contract. Then we get into my favorite part, front-end libraries. So Ethers and Web3.js, right? These allow you to talk to the blockchain without all that JSON RPC mess, right? They kind of bundle up some of these things for you and make it a lot easier. So you're going to work with Ethers.js. It's pretty much the de facto new JavaScript library for most companies, but the older ones still use Web3.js. So if you want to just get familiar with it, you can. I personally would focus just on Ethers, right? They tell you some of the advantages. You can do everything Web3.js can. MIT license, free to use, allows modifications, smaller size. It already comes out ENS compatible, which is super nice, right? Especially nowadays. You can just use someone's ENS name to send transactions or whatever it may be. It's well tested, but it's newer. Less documentation, less people working with it, less people being, finding Stack Overflows or Stack Exchange Ethereum and finding kind of those answers. Your final project will be creating a block explorer. So Etherscan, Polygon Scan, Binance Scan, right? You guys are going to make one of those. And you'll be using the Alchemy SDK to interact with and make this. It's a very open-ended project. So for us, for grading this week, we're going to be grading it based on the amount of features implemented and how creative you get with your CSS this time, right? So we have CSS preprocessors and we have frameworks. I suggest for all of you who are very weak in CSS, you either pick up CSS, SAS. You could do post CSS, but CSS, SAS, React has ways to even use post CSS as a preprocessor for your SAS, so if you're worried about efficiency. But just so you're aware, obviously there's a bunch of other frameworks, right? We have Tailwind UI, Material UI, and then we have kits like Web3 UI Kit, and these things are all super nice. And when you get good with CSS, that's when I suggest using those things, right? Because they make it very easy for you to create good designs, but because it's so easy, you never really learn the fundamentals of CSS. And that's pretty much it this week. I'll show you this because this is what your project is to make. Now, it doesn't have to exactly be this, right? You don't have to necessarily have all this data, but go crazy as much as you want to do. It's only going to challenge yourself. And then I also want to show you guys Web3 UI Kit, because while I don't think that you should use it, if you start having like extreme trouble with just CSS, like it's just really killing you, then yeah, you can come and use this. They have an official guide for using it with Next.js, and they also have an official guide for using it with React. And they pretty much have all of these components that come out the box, and they look pretty, and they look like what we know and love already, right? They look like OpenSea, they look like all the apps. But with that issue is, of course, your apps are always going to look kind of similar to something else. But it does help with the user experience. And on that note, I think we're good to break out, unless anybody has any questions today. Yeah, absolutely.
So this is more just based on the earlier part of your presentation. So one of the pillars of Ethereum is, censorship resistant. And, ever since the Tornado Cash debacle, you hear a lot about, transactions that are not OFAC compliant being excluded. Is that taking place within the nodes, or where exactly is that like censorship kind of taking place? And also like what tools and stuff out there are kind of help push forward this censorship resistant pillar of Ethereum?
That's actually a really good question. And I think that we'll actually go over that in just a few minutes. And we'll answer that and give you guys some more information about censorship, what's going on, why things are being censored, and kind of that stuff. So we'll talk about that over there. Are there any other questions?
Is this a UI kit kind of like a storybook, but specifically for that Web3 UI library that you recommended to use for CSS?
Yeah. This is pretty much like Storybook. Like they have like, it's like, if you want to use this one, like it's gonna come with.
And it only works if you use that library.
Yeah.
Web3 UI. Okay.
Yeah, Web3 UI kit for this one.
Cool.
Yeah,
Cool.
yeah.
Thanks.
Yeah, no problem. Any other questions? All right. Absolutely. All right, we're good to break out then, and we'll all talk soon.